So now we'll solve some numericals on viscosity, their types, fundamental numericals on viscosity. So first numerical, if the velocity distribution over a plate is given by u, that is velocity u is equals to 2 by 3 y minus y square. This is the equation, that is velocity profile, in which u is a velocity in meter per second at a distance of y above the plate, where y is the distance as we discussed in our theoretical part. Determine shear stress, that is tau, we need to find out at y is equals to 0 and at y is equal to 0.15 meter. So that means you have been given two values of y. At y is equal to 0 means at plate surface, and at y is equal to 0.15 meter we need to find out shear stress, which is equals to tau. So shear stress tau I need to find out with the two value of y is equal to 0 and at y is equal to 0.15. So this is a given problem. We'll start. So very simple equation, u is given, so I'll solve the problem. Velocity distribution u is given 2 by 3 y minus y square. So as we know, this velocity gradient is taking a derivative of this u, so derivative of u du with respect to y, so y. So derivative of this y is 1 because we are taking derivative with respect to y. So 2 by 3 derivative of y is 1, so into 1, so that is 2 by 3 minus derivative of y square is 2y. Now this the equation which we got, that is velocity profile du by dy. So very simple problem, we need to find out shear stress at 2 points, y is equal to 0 and y is equal to 0.5. So what I will do first part, I'll find out the value of this du by dy, value of du of dy at y is equals to 0. So it simply put y is equal to 0 in this equation. Let's say equation number A. So in equation A, put y is equal to 0. So 2 by 3 minus 2 into 0. So that is simply 2 by 3 because minus 0. 2 by 3 minus 2 into y value is 0. So I'll get the answer 2 by 3. Similarly, I'll find out this again value of du by dy for y is equals to 0.15 meter. Same equation number A, put value of y, that is 2 by 3 into 1 means same 2 by 3 minus 2 into what is the value of y? Y is now 0.15. So it will be 2 by 3 minus 0.3. So I'll get answer as 0.367. Now in question they have given one value which you can say very important, as take a dynamic viscosity of the fluid is 8.36 poise. Remember, it's a CGS unit given poise which you need to convert in SI unit. So how to solve the next part? Simply first convert this dynamic viscosity, mu is given as 8.63 poise, so which is equals to in SI unit just multiply by 10 raised to minus 1, or you can say it's divided by 10. So always to convert any this factor dynamic viscosity means viscosity from poise to SI unit, you need to divide by 10 or multiply by minus 1. So it will be just this point will shift on this side, divided by 10, so 0.836 Newton second per meter square. Now, very simple last step. Put the values in this equation of Newton's law. Tau is equals to mu du by dy. Now first, what is mu value? Mu is this 0.863. Now there are two parts. First part, we need to find out du by dy at y is equals to 0 and du by dy at y is equal to 0.15, that we already calculated. So it is 2 by 3 for 0 and for 0.15 it is 0.367. So first part, tau is equals to 0.863 into du by dy at y is equals to 0. So I'll say tau 0 is equals to this 2 by 3. So your first answer means shear stress, which is asked, shear stress at y is equal to 0. So tau 0 is equals to 0.5756 and unit will be Newton second per meter square. Newton second per meter square. Similarly, second part will be, now I'll change only the value of this du by dy at 0.15 meter. So second part will be, again I'll use another. So now tau is equals to at 0.15. So tau 0.15 is equals to mu into du by dy. Mu is 0.863 and the value of du by dy at 0.15 is 0.367. So this is 0.367. So you will get the answer tau 15.15 is equals to, just multiply by this dynamic viscosity 0.863 into 0.367, you will get answer as 0.3167. Unit will be Newton second per meter square. So this very simple numerical question was velocity profile, u is equal to 2 by 3 y minus y square. Find out velocity gradient du by dy. Just derivative of y is 1, y square is 2y. So in this equation of du by dy, I just put y is equals to 0 and y is equal to 0.15. So I got two values of gradient, 2 by 3 and 0.367. Mu is given 0.863 in SI. Just take a conversion. Don't forget to convert this, otherwise numerical will be wrong, because we are using SI units. So at two part, first part is tau mu du by dy at 0. So tau 0, just put the value of du by dy 0 and mu. Same second part, slight change, just put the value of du by dy at 0.15. You will get two different answer, that is shear stress at y is equal to 0 and at y is equal to 0.15. The next numerical now, similar to the previous part, basics, viscosity. Now here in this numerical, the question is a plate 0.025 mm distance from a fixed plate moves at 60 cm per second. So there are two plates, one plate is fixed, another is moving. The moving plate velocity is given, that the velocity of plate is as mentioned 60 cm per second. So that's velocity. The distance between these two plates is 0.25 mm, and it requires force, very important, it is force per unit area. So this term given 2 is force per unit area, which I again mentioned here, it's a Newton per mm square. So that is, it's basically a stress, not exactly force. So tricky sentence, force per unit area, so that's a 2 value, it's a stress, not force exactly. To maintain the speed, so to maintain the flow or to maintain the speed of the plate at 60 centimeter per second, force applied is 2 Newton per unit area. What we need to find out, fluid viscosity between the plates. So here we need to find out viscosity. So yes, absolutely, it is a dynamic viscosity. When it is mentioned only viscosity, consider this as a dynamic viscosity as mu. So we need to find out mu value. So we'll solve this numerical. So what is given, a distance between the plate is given, so that is small dy is mentioned as 0.025, which is in millimeter. Velocity of upper plate, so consider this as u, or you can even consider this a change in velocity du, which is given 60 centimeter per second. So 60 centimeter per second. So convert this value in SI. So I'll just take the 60 as 0.6 meter per second. You can convert similarly dy as 10 raised to minus 3 meter. Now as mentioned, force per unit area is 2, which we know as, which is a shear force per unit area. So I'll say shear force per unit area, which is directly given as tau. So tau is given 2 Newton per millimeter square. Now just we'll take this value now, because 2 is a very large term, so I'll take this value as not, it's meter square, just see this as meter square. So just consider tau is 2 Newton per meter square. Now we'll solve this numerical. Tau is equals to mu du by dy. So shear stress is 2 Newton per meter square. Mu, which we need to find out, du is 0.6, whereas dy is 0.025 into 10 raised to minus 3. Just take conversion to the SI unit. So from this, just find out this term and take on this side. You'll get the answer, dynamic viscosity mu is equals to 8.3 into 10 raised to minus 5 Newton second per meter square. So as we know, this Newton per meter square is also Pascal, so you can say Pascal second. So 8.33 into 10 raised to minus 5 Newton second meter square or Pascal second. If you want to convert this in poise, so that will be simply just multiply by 10. So 8.33 into 10 raised to minus 4 multiply by 10. So it will be poise. So this is your answer, very simple part. Calculation of viscosity. Remember, in this problem just consider Newton per meter square. I have taken Newton per meter square, so just put value of 2 here, du as 0.6 meter per second, and this 0.25 into 10 raised to minus 3 meter. So you'll get simple, very simple numerical on calculation of viscosity. Now next part is one more important numerical which indicates again calculation of a viscosity related parameter. A flat plate of area 1.5 into 10 raised to 6 millimeters square. So the area of the plate is given mm square, 1.5 10 raised to 6 plus 6 with the speed 0.4 meter per second. So velocity u is given. So you know in this problem du area relative to the another plate located at a distance of 0.15 meter. So the distance means y is given. Find out force and the power required to maintain this speed if the fluid having viscosity is equal to 1 poise. So as unit is poise, it is a dynamic viscosity. So very simple numerical again. So take this nu is equals to 1 poise. So just conversion of 1 poise into SI unit will be 0.1 means SI system divided by 10 Newton second per meter square. So mu is 0.1. Velocity as it is given du change in velocity which you can take 0.4 unit is meter per second. Distance the dy small change distance is distance between the plate 0.15 which is millimeter 15 millimeter. So just take a conversion 10 raised to minus 3 meter. So mu as a viscosity 0.1 in SI system Newton second meter square, velocity meter per second, and this dy is given. Now very simple part, shear force, we need to find out shear force. So shear force F is equals to, as we know, shear stress tau is equal to force upon area. So force is equal to shear stress into area. Area of the plate is mentioned, it is clearly. So I'll say the force F is equal to shear stress tau, which I can write as du by dy into mu. So this is the equation of Newton's law of viscosity. So tau is equal to du by dy into mu, that is tau into area of the plate is, which is given 1.5 into 10 raised to, as it is 10 raised to 6 millimeter square, you can convert this for meter square. So accordingly it is 10 raised to plus mm square minus factor, so it will be a simple factor as 1.5. So 1.5 meter square as area. Put the value of all these factors, so I'll get the answer. This du by dy, du is given 0.4 divided by dy, dy is 0.15 into 10 raised to minus 3 multiply by 0.1 into 1.5. So this is total force, which is a shear force as 400 Newton. 400 Newton is the shear force. This is your first answer. And the second part, which is power required. So what is the power formula? Power is equal to force into velocity. So I'll take a same, power is equals to force, shear force into velocity, always force Newton into meter per second. So force which we have calculated is 400, shear force, velocity is 0.4. So the answer for this will be 160 watt. So power is equal to force into velocity. Force unit is Newton, velocity is meter per second, and as we know Newton meter is joule, and joule per second is watt. So that is the unit for power. Power is equals to 160 watt from the unit of Newton meter per second, that is joule per second energy rate, that is power consumed by corresponding fluid flow. So that is complete numerical for viscosity based parameter. In this it was a very simple factor which were calculated from a Newton's law of viscosity, and additional this formula power is equal to force into velocity, and justification with this unit for it.